to some of the geometry chapters of the book, and they are shorter. And just based on where we have already been, I'm going to be taking them a little bit out of order. We're going to start here at 15.5, and then throughout the week, we're going to kind of backtrack a little bit into 15.1, and this idea of thinking of a solid figure unraveled, like unfolded, and calculating not only volume, but the surface area of the shape, and learning different kinds of nets. Have you ever heard of the term net before? A net is a three-dimensional figure that's folded up. It's sort of like the pattern needed to make a certain three-dimensional object. So I have an activity planned for us later in the week on Friday, where we're going to be making a net family. So stay tuned for that. But today it's as simple as this: using a formula to calculate volume. So remind me, what does volume mean? Maybe let's read that little opening sentence to jog your memory here. The volume of a rectangular prism is V equals L times W times H, where V represents volume, L represents length, W represents width, and H represents height. So it's a three-dimensional measurement, and that involves the entire density of the shape. Like, how much space does this object contain? Have you been studying density a little bit? A little bit. So density is related to not only like the temperature, but also the size of the shape that it occupies, right? So volume is related, and we need to know how to calculate volume based on different measurements that were given using fractions and decimals. So we're going to just be basically plugging in some measurements and calculating the overall volume. On this page here, you can see that there's only fractional measurements given, but I am going to convert one of them here on the page so that you can see the very same approach works for numbers that are in decimal format as well. Does that sound good? So we're going to do this whole page together, and then we're going to preview what's to come here on this page, and then I'll let you work. All right, before we start this, how is area different than volume? So area is a measurement of space, right? But what kind of space? Tell me what you know, Isaac, and then we'll build off of that. A two-dimensional space, so a flat space. But volume is a three-dimensional measurement, and it is revolving around not only the length and the width of something, but also its depth. So we'll always have 3 units of measure involved for volume and 2 units of measure involved for area. Do you notice the units up above here? When we give the total answer, what exponent is involved in the answer here? To the third power, right? Because you're talking about how many dimensions for volume? 3. So you're going to use that exponent to indicate how many inches in the third dimension, okay? If this were an area worksheet and we were only doing length times width, what would that exponent be? 2. And if the exponent were 1 or invisible, just inches, that's a measurement of simply distance. So 1 length, 1 measurement would be just inches. All right, let's get to work here. You do not need a calculator. These are all going to be super simple. Let's remember how to multiply with fractions. Do you need common denominators with fractions for multiplying? That wasn't a very definitive yes or no. What do you think? Do you need common denominators? No, you don't. So really, we're going to just use this volume formula. Everyone on this line right here, right? V equals L times W times H. And then we're going to go and replace each of those in the line underneath. V equals, which one would you say represents the length? And does it matter? It doesn't really matter, does it? In this case, because you could just tip that box on its side and maybe you understand the length as being the one that goes horizontally along the bottom. But as long as all three of those numbers are being multiplied together, multiplication is what property that allows for reordering? Starts with the C, commutative. So it doesn't matter, right? I'm going to just grab each of these terms, 2 1/4 times 2 times 1 1/2. As long as all three of those are there, we're good to go. Okay, remind me of what to do when I'm multiplying with mixed numbers, with fractions. You told me I don't need common denominators, which is true. I have this snap across algorithm, right? Am I ready to snap across yet?
No.
No, what do I have to do before I can snap across? They have to look like fractions so that they act like fractions, right? So you're right. We have to convert them to look like fractions, not mixed numbers, not whole numbers. How would I convert 2 1/4 into looking like a fraction? Katerina, what do you think?
You have to I don't know how to say it, you do that little arrow thingy.
Yep, that little around the world trick,
Yeah.
and you
And then
make it mad.
3 times 4 and then plus 1.
Yep, 4 times 2 plus 1 is what? 9. And we keep the denominator. Here, I'll just write it next to here. 9/4 times, what would 2 look like as a fraction, class?
2/1.
2/1, as Shane likes to say, 2/1. And then what would this mixed number be converted into improper fraction?
3/2.
Over 2, you got it. All right, so we can see if there's any opportunity for kind of cutting down the factors. Notice how there's a 2 on the numerator and the denominator. I can reduce this fraction before I multiply or reduce it after I multiply. It would be easier to do it now. Then my numbers are smaller. This factor changes to 1. And now there are no other factors in common. So I just snap across. What is 9 times 1 times 3?
27.
Okay, 27. And what would 4 times 1 times 1 be?
4.
4. All right, so I'm at the spot now where I have an improper fraction. How can I rewrite that as a standard form mixed number? I ask myself what, John? Yes. Yes, 27 divided into 4 parts gets me what? What whole number?
6.
6 whole times. That would make 24. So what's the difference between 24 and 27?
3.
With 4 left, oh yeah, 3/4 left over. All right, that's the number answer. What do I need next to it? That's the number. What do I need next to it? Alicia, what do I need? I need the unit involved. And to what dimension is yards? Third power, yep. So I put a little 3 up here in the exponent zone. So yes, this is my, I know it's kind of lengthy here on my paper. You can probably write tinier than me, but this is the entire answer. You have a number and a unit. That's the entire answer for number 1. Go ahead, set up, convert if needed, snap across, simplify number 2. Go ahead. Are we on the same page here? How are we doing? 10/3 so far? Are we getting there?
Yeah.
Which would be 3 1/3. What are my units of measure here?
Meters.
Here's what? Meters cubed. You got it.
Why did you X out the 6 and 4? Because I got 3 and 2 6.
Which reduces to 1/3. Right? So all I did, I think that was page, all I did was remove their common factor of 2 before I multiplied, and then you have to do it after you multiplied if you didn't do that. So 4 and 6 both have a common factor of 2. What's left over? 2 is left with the 4, 3 is left with the 6.
Would it matter if you changed the order of it?
Nope, because multiplication is commutative, right?
Yeah.
I'm hearing some people in the room asking me, why did I cross out the 4 and the 6? So let me just backtrack a tiny bit here.
I understand the 6 and 3, but I don't understand 4.
So notice here when I have 3 can reduce with the 3, or you could have done the 3 with the 6, right? Because they both share common factors, but you can't go like 3 ways. It has to be one numerator factor with one denominator factor, remove them. Do you remember when we did those Lego blocks? You have to kind of think of factors as being tangible things. And you can only remove one pairing of them. They can't cancel out anybody else that they aren't matching. So what I chose to do was eliminate this 3 and this 3. Since they were both 3, what factor does that change to? A 1. And I chose to say, well, 6 and 4 share a common factor of 2. So let me reduce this by 2. Reduce this by a factor of 2. And then I snapped across. But if you didn't do that part and you just reduced the 3's, what would you get? You would get 20 over 6, which Paige said she got 3 and 2 6, right? She's right, but she's not simplified down all the way. What can she reduce? 2 6, right? And what can 2 6 become? 3 and 1/3. You got it. So either way, you go after it. We ended up with the same solution. I just simplified before the multiplying and she simplified after the multiplying, but I don't mind which version you do. Does that make sense?
Yes.
Okay.
Yes.
Let's set up 3 and 4. Now we don't have a picture to complement it, but we know by now that the volume formula is just these 3 dimensions.
Do you still want to put V equals?
It's helpful because it drills that formula into your brain. But would you say that the volume formula for maybe a shape like this would be a little bit different? Or would it be length times width times height for this shape too? It'll be different because there's not all of these extra space, right? It's a circular shape. So the volume formula for this shape would be different. What about the volume formula for like a pyramid type of shape? It would be different. This is just volume of what type of shape? Prism, a box, something that represents rectangular faces on all 6 sides. Notice none of them are curved. None of them are triangles, right guys? These are all prisms. How about we do number 3 here real quick, and then we'll split up the work here between boys and girls, okay? We'll do 3 together. So V equals length times width times height. I'm going to kind of convert them as I go here. 3 times 1 plus 1, 4/3, 1/2. That one's already in fraction form. height 3. Anywhere to reduce or cancel? What can I reduce or cancel between the entire numerator and the entire denominator?
3 and 3 and 4 and 2.
Yep, the 3's can go. Those are eliminated totally, left with a factor of 1. And what about 4 and 2? Can I reduce these guys?
Yeah.
Yep, by a factor of 2. All right, nothing else to simplify here. Snap across. I have 2 over 1, which is equal to just 2.
2
2 what?
feet.
Don't stop there. 2 feet cubed. 3 dimensions. I need 3 copies of feet in there. All right, number 4, I want to convert to decimal format just to give us something a little bit different to try. All right, so do you remember the decimal version of 1/2? What's the decimal version of 1/2? 0.5. So 1.5 would be 1.5, right? I'll remind you of the one that is 3/8 is 375. Okay, and 4 would just be 4. How would we multiply 3 decimal numbers? Could we multiply all 3 of them at the same time? Or do we need to do like chunk by chunk?
Chunk by chunk.
All right, so which one would it make the most sense to put up on the top?
2.75.
2.375 because it is the most digits, and that would force the bottom number to be smaller, and therefore you have less partial products to manage, right? So we want to put the one as the most digits up on the top. So let's handle it like this. Everyone writing this off to the side, 2.375. And I don't mind if we pick times 4 or 1.5, doesn't matter. But let's do 4. How do we multiply with decimals? You don't have to align the decimal zones, right? Multiply like regular, then count your decimals place values. All right, what's 5 times 4? That's 20. 7 times 4 plus 2, that's 30. 3 times 4 plus 3 is 15. 2 times 4 plus 1. How many decimal zones are in my answer problem? 3. So that means 3 are in my answer. 9.50. We can just get rid of those guys, right? Now let's multiply by the third term here times 1.5. All right, 5 times 5, 25. 9 times 5 plus 2. Drop a 0. Are you writing this in your book? I want to see evidence of you participating in class, please, here. Combine them. 5, 12, 14, 2 decimal zones, 14 and a quarter inches cubed. So would you think, just by how much work was involved, would you prefer working with fractions or working with decimals?
Fractions.
Okay, so fractions give you this ability to like reduce it down and make it quicker. But sometimes if there's smaller numbers with really nice short decimal values, then maybe converting them to decimals would be your better bet. What would this number be in a fractional form? Still be 14 would be the whole number, but what would the fractional part that matches 0.25 be? Come on, you know this one. What does it match? 1/4, yes, 1/4. Yep, so that's the fractional version if you would have lined them up with fractions instead. Okay, boys do number 5, girls do number 6. And I don't mind if you convert them. It's going to be a little tricky though with thirds and 6. They they have repeating decimals, right? So maybe just for the sake of accuracy, we keep them as fractions for these two. Let's keep them as fractions. Boys do number 5, girls do number 6.
But for your simplifying, does it have to be numerator by denominator, or can it be denominator by denominator and numerator by numerator?
When you see a common factor,
Yeah,
as long as they each have one, you can,
so it doesn't matter which side of the fraction you're on.
no.
Wait, so like let's say it's half and 1/4. You can do the 2 and the 4, which are the denominators.
No, I think he means when you're reducing, does it matter where,
No, I'll say what, like Leanna said, 1/4 times 2/4, when you make the 4 both 1. Can you make both the 4 1?
oh, I misunderstood you. I thought you meant when you do it that way. That's the opposite operation then.
No, I'm talking about, okay.
Yeah, just do it the first way that you mentioned. Okay. How did you guys convert 1 and 1/4? It's 5/4, right? And this guy is 7/3. And this guy is 1/6. Lots of opportunities here for reducing, or no? I don't see any opportunities for reducing, do you? For that one? There's no common factors between the numerator and the denominator. So you're stuck just multiplying straight across and seeing if that's as low as it can go. If you can't reduce it on the front side, you can't reduce it on the back side either. So that's going to be kind of a large number. All right, ladies, what did you convert 5 and a third to be? 16/3. And the second term here? 7/2. I see already an opportunity for reducing. All right, and then this one here? 3 times 1 plus 2 is 5/3. Okay, so a little bit of opportunity here for simplifying. This 16 and this 2 reduce. So that would change this to an 8. But still, it looks like you're stuck with some pretty big numbers, girls. All right, guys, did you get your final answer yet? Numerator, go. 35, denominator.
72.
And what's my units, guys? Feet to the third power, which is called what? Cubed. This is called cubed. So 35/72 feet cubed. Ladies, what do we get here?
Mrs. Moore,
Yes?
for the boys, couldn't you simplify 35?
35 and 72 do not have anything in common. Think about their Lego prime factors. 35 only has 5 and 7, right?
Mhm.
72 has 2, 2, 2, 3, 3. They don't have anything in common.
So like you
I thought you
Can't simplify it.
You can't do 35. Oh, okay. I misunderstood.
I think you're thinking it was an improper fraction. You needed
Yeah.
to divide. No, it's a proper fraction, so it's done. But the ladies' side, do you see this, girls? Is that one done? No, it's an improper fraction. So that's when you divide and then take care of the leftovers. So how many times does 9 go into 280? How many times? I'm hearing 31. So that means 31 whole times. And what was it? 1 left over? Like this?
Yeah.
And my units, please? Yards. Cubed. Cubed. All right. Slide down to the next page here. 1, 2, 3, 4, exactly the same. I would expect to see your like conversions, your reducing, your simplifying. Keep them in fraction form. Tomorrow we're going to do a little bit of some decimal action, but we're going to keep these in fraction form.
Wait, Wednesday?
Yeah, Wednesday, sorry. Same type of work. Someone has performed the volume formula, but they've done something wrong. explain what they did wrong and what the correct volume is. Number 6 gives you dimensions of a box. A box is what type of shape? A rectangular prism. So you can use the volume formula we learned today for anything that has rectangular faces on all 6 sides. Down here on number 7, when they have this big uppercase B, do you know what that refers to? That's a measurement of an object's base. Base what? Base area. So maybe label that B as base area. That's what B stands for. So explain how the formula of base area times height and the volume formula we learned today are related. Are they the same? Are they different? How are they related if you know that B represents base area? Okay. All right, I'm going to finish checking in assignments here. Anyone at home need anything else before we go? Okay. We do not have math class tomorrow, so enjoy your little break here. We'll pick up again on Wednesday with some more 3-dimensional figures. We're going to do a little scavenger hunt of sorts for our class and homework for that day, okay? I will see you next time. Bye, guys.